Hi! In this series, we'll be doing multivariable calculus. And before we start on the calculus part, we first need to understand what are vectors and what are the things we will be talking about when we study multivariable calculus. And this arises from understanding the Euclidean space first. So, we'll give a brief recap on vectors before we actually do limits and differentials on vectors. Let's begin. The Euclidean space is the set of n tuples for Rn where each component, so these are the coordinates, is an element of real. So it's actually R times R times R times all the way times R n times. And then you just simplify it and write Rn. So from what we know, Rn is a vector space, meaning it's closed within additions and scalar multiplication. And these are the operations that you can do with the elements in the vector space. And the elements will be represented by this Cartesian product n tuple. So you can either write it horizontally or you write it vertically. There's no difference. So a classic example, and one that we'll always be using throughout the whole series, is Euclidean 3-dimensional space. And the reason for this is it's a generalization from the 2D space. So you can have more parameters and it is something that you can draw out. So it makes visualization easier. And once you understand 3D and how it extends from 2D, you are able to extend it further, and Rn is quite simple from there. So really, 3D is what we really want to understand. One thing to note is that the distance between 2 points will be given by the standard Euclidean metric, which is square root of x1 minus x2 squared plus y1 minus y2 squared plus z1 minus z2 squared. So what are vectors? Geometrically, a vector is an ordered triplet. And what we want to understand from vectors is that when we are given a vector, we can represent it by an arrow. So earlier I've said that the points in the vector space are also ordered triplets. But we can also think as the ordered triplets as understanding it from going from one point to another. For example, Q is x plus a1, y plus a2, z plus a3. Then P is x, y, z. Then moving from P to Q, you have to move a distance of, in the x coordinate by a1, y coordinate by a2, and z coordinate by a3. So you're to move, and then if you connect a line from P to Q and then draw an arrow, means you're moving from P to Q. You're really moving a1 plus a2, a1, a2, and a3 in that direction, we call it. And so P will be called the initial point and Q is called the terminal point. And so now you might be wondering, why is it the ordered tuple can represent this arrow and it can also represent the point? Well, that's because the point is actually an arrow from the origin. So you can imagine your point as a vector from the origin. And so this arrow actually is called the position vector. And that's why we can also think of points as position vectors. And this position vector now, it really means reference to the origin. But if we have a similar vector over here, it could also represent this, it could equal to this if and only if the tuple is the same. So x1, x2, x3 equals to a1, a2, a3, if and only if x1 equals to a1, x2 equals to a2, and x3 equals to a3. So in any cases, all the elements in Rn can be called vectors. Whether you think of, so it's good to understand when you want to think of them as points and when you want to think of them as vectors. And doing more questions will help you understand that. So let's talk about the operations. So algebraically, when you add vectors, you just add them component wise. And geometrically, it means that you extend the arrow by going in first A directions, then B directions. For scaling, it's just like stretching or squeezing the vector. So if at first you move A steps, and then now you want to move 2A steps, you just extend it. And if you want to move backwards, you just multiply it by a scaling factor of negative. Another operation that we can define on vectors is known as the dot product. And the dot product is defined to equals to the summation of ai bi. And what does that mean? For example, if it's 3 coordinates, it's a1 times b1 plus a2 times b2 plus a3 times b3. And then you add them all up. And then after you define what is a dot product, we can define the length of u to equal to the square root of the dot product between itself. And the reason for that is because it follows with the distance formula that we want. Because if we already said that the distance formula between 2 points is you take the difference and then you square it, then actually the length it resides with that understanding to be a distance. Another way of saying it is a metric, and so Rn forms a metric space. To understand what's a metric space, you can watch my analysis videos. And a unit vector is a vector whose length is 1. And so, a vector is actually coming with part of a length and a direction. And so this direction is the unit vector parallel to v. And so really the unit vector represents the direction, and the magnitude or the length of the vector is the scalar multiplied to this unit vector. Also, what's good to know is that there's a standard unit vectors, and this is known as a Euclidean basis, where I is 1, 0, 0, j is 0, 1, 0, and k is 0, 0, 1. So this is the standard one that we always take when we ever reference the 3D space, unless stated otherwise. Lastly, let's talk about one use of the dot product, and that is really finding another definition on the dot product in terms of the angle. And how does this definition arise is by the cosine rule. And you note that a minus b, the length squared, equals to a squared plus b squared minus 2ab cosine theta. And a minus b squared is actually a minus b dot times a minus b. And if you expand this out, it's this. So when you equate them, you actually see that cosine theta actually equals to a times a dot b over the length of a multiplied by the length of b. And so you can see that if a dot b is positive, then the angle between them will be acute, and if a dot b is negative, then the angle between them is obtuse. And if they are perpendicular, meaning orthogonal, then a times b is equals to 0, because the angle here is 90 degrees. And so the dot product can be also represented by u the length of u times the length of v cosine theta. And this allows us to find the angle between two vectors. And one thing to note is that if they ask for the angle between lines, it's always taken to be the acute angle. Because lines don't have directions, they're just lines, they're just objects in the space. So this will always be the acute angle, will always be the angle between lines. But because vectors have a direction, if for example the vector is here and here, now of course this is the angle that you have to travel. So that's why the angle, you don't need a modulus here. But if it's the angle between lines, you just put a modulus. Hope that's clear. So I've come to the end of this video. We'll be continuing our journey to understand more about vectors first before we actually do the calculus part. But understanding more about vectors will really build our visualization on how we can view what we want to study. So it's good to study about vectors first. So that's all. Feel free to like, share, and subscribe, and I'll catch you in the next video. Bye!